Welcome to the Intersecting Us podcast, where math and life intersect.
In today's podcast, Dave and Brian discuss math beyond numbers, nurturing imagination and education. Dave and Brian first delve into the previous podcast to clarify math, faith, and certainty, finding the balance in life's equations.
Well, what if you could look at math in a different way? What if you could look at life in a different way? Today on our podcast, we're going to try to imagine math in a new way. And we did a little bit of that last podcast or a couple podcasts ago. And this is Brian Reiner, and I'm here with Dave Kester on our Intersecting Us podcast, looking at math and life and intersecting all those types of things. But Dave, we talked a little bit about math, awakening your imagination, some of the concepts that surround that. But I know we kind of got to the end of the podcast last time, and I know you had some more you wanted to clarify. So why don't you start us there and kind of clarify some of those thoughts you had coming off of that?
Sure. Welcome, everybody. It's always a pleasure to be here. And the topic for today, the imagination math, is a pretty exciting topic for me. So I can't wait to jump into it. But I kind of left everyone hanging a little bit in our last episode. So I thought, well, maybe I will. I'm not going to close the loop, but maybe at least put a little bit of thought to it, to a topic that is something I know both you, Brian, you and I have a lot of passion about. And that is how we talk about the differences between certainty and faith. And I know we can talk about faith in a lot of different ways. I know, Brian, you've got some thoughts on like how we can think about faith. What are some ways you think about what does faith mean to you?
Well, I think, and that is subjective. We want to think about what it means to us. Ultimately, it can mean lots of things to lots of different people. But historically, that word has had a fairly concrete meaning. It may move around. Usually we associate it with religious ideas, and that's fine. But we use it for other things too. You might say, I have, faith in Newtonian physics or something, so we can use it outside of a religious context. But historically, it's always been a very close word. Instead of, in some languages, it's almost the same word as trust. Mm-hmm. So that's where I always kind of couch it. I know lately, probably the last generation or two, especially in the Western world, I'm not really certain in the Eastern ideas, but you see that term, which I don't like, the term wishing coming in there. And that really never is what faith is about. So, yeah, I guess the last thing I'd say at this point on it is, and I've used this analogy before, many people have, think about a bridge that somebody has built across a big cavern or a canyon, and you're going to go across. And if the bridge doesn't work, you die. I mean, that's really where it comes to. So you can say, somebody could say, well, I built this bridge. Would you want to go across it? And somebody could say, me? You want me to go across it? I'd say, okay, well, that would take some faith, would say. Mm-hmm. But would you say, if you want to use the old version or the really classical way of looking at faith, which is trust, do you have enough evidence in everything that's gone into that bridge that this will get you across? Mm-hmm. And this right. You can kind of segue into your certainty on this too. And if you want to use this, or if you have a different analogy, that's fine. But it would be kind of silly for anybody to say, well, yeah, this guy doesn't even have a degree in engineering. It looks like it's made of paper mache. And, it's like, but I'm just going to have faith. I just hope and wish that it goes with no evidence. It's like, well, I don't think that's faith. I think that's stupidity. And so, yeah. So I think that's where I would come off of it, that it's right. Trust in something with evidence. I think the evidence is important. It might not be compelling evidence to everyone. That's fine. Mm-hmm. But to say somebody doesn't have evidence, then I don't really think that's what we're calling about faith or trust.
Sure. The word that comes to my mind is blind faith. And so it's if you have no logical thing to back it up, you're just going by blind faith. But generally, we attribute faith as to something that we may have a high degree of confidence in, but certainly not 100%. And the point I was trying to make in our last podcast was that often what I've seen is when people talk about elements of faith, and usually faith has to do with a lot of things that have happened thousands of years ago. So how certain are we of things that happened thousands of years ago? Well, there are a lot of documents out there. So we have some certainty, depending on what we're talking about. So it's not blind faith. There's a lot of evidence, but it's not like we were there, that we were eyewitnesses. And so I think what we get into trouble is when we exchange faith for certainty, and we talk about things as if they're certain. And we know in math, 2 + 2 = 4. That's something that we are highly certain about. But when we talk about things that have happened historically, then I think that enters more into the realm of faith. And it may seem like a small nuance, but I feel like if you talk about certainty, you don't allow room for other people's different opinions on it. And I think that's where we get into trouble, is when we squeeze out other people's perspectives, because we have such of a strong faith in what we personally believe in. And those are things that I think that go down a dangerous path.
I agree. I do think, again, that, it kind of comes back to some of the stuff we've talked about in the past, having a little bit of humility, especially when it comes to ideas that do have some nuance to it, whether it's to do with history or what we would call forensic evidence, stuff like that, where you don't always have complete certainty. Most of what we do in science is that way, or just detective stuff. If you like that kind of stuff, that's usually inductive. You're trying to get to the best possible explanation. You might not be 100% certain, but you have some faith that this is the best one. And we do that all the time. Yeah. And I was just thinking about that. I was on a jury a couple times, and people have probably been on juries, and they tell you, that you're supposed to come up with conclusions that you trust. I don't know if they use the word faith, but trust that we're right beyond a reasonable doubt. Not an unreasonable doubt.
Mm-hmm. Right.
Yes, a little green man could have come and shot the guy, and it wasn't the guy in the room. It's I suppose that's possible in some sort of universe, but that's not reasonable. And I think that's what we're doing. We're trying to find a reasonable inference to things. And so when you look at faith, trust, is there enough evidence to trust this over not trusting it? It's probably the first. Is it more, as the old philosophical idea, is it more plausible than not? In math, that one is easy. I mean, like you said too, but that's not, you can empirically prove math so easily. Well, when you get into life science, forensic science, even just, cosmology and all that, I mean, there is some, you're not 100% certain, but it's more plausible than not that this is true. And I think that's what you're kind of trying to get at, I think. Yeah.
Right.
Next, Dave and Brian go on further to explore the boundless imagination of mathematics.
All right. Well, cool. Well, I'm sure this won't be the last time we talk about it, but in order to give a little bit of time for our imagination today, let's jump into today's topic. We talk about how to imagine math in a new way. And, I think one of the things that we think about as humans is that we have a lot of limitations. We are humans, and so therefore we have limited time, we have limited ability to think, and so forth. And so often we think of ourselves as limited by circumstances, but we are usually not limited by imagination. And I know that most people don't think of math as something that requires imagination. In fact, we just talked about how 2 + 2 = 4. So there really wasn't any imagination in that exercise of that equation, but that is such of a small part of math. And if you look at math as a whole, it is very much an imagination type of a experience. And I want to kind of touch on that today to open some people's eyes to how imaginative math can be.
Yeah, and I do, as we've talked about this before, kind of the difference between, and I'm always a stickler on this, almost to be annoying, when somebody says, I think I've said this before, but when somebody says, may I pick your brain? I said, well, no, that would hurt, but you can pick my mind if you want, and I think that's what you're kind of talking about here. And a little bit of the imagination is something that isn't, well, especially when you're looking at math, it's not bound by anything. There's not like you said, you're limited by your circumstances. Certainly we are bound to some extent. I'm in an office where we're podcasting here. So are you. I can't, teleport to where you are. You can't, and we can't teleport to the listeners and all that. We don't have that ability, but we can think about them. Mm-hmm. We can think about, if you know who they are or whatever. So our minds are really only, I was going to say they're bound by probably our own laziness almost, I guess is the word I'm thinking. We're just not, we don't engage them enough maybe, and let the imagination go. It may go down paths that may not ultimately be fruitful, but sometimes you have to go down paths like that before you get to one that actually becomes useful.
Mm-hmm. Right. And so if you take something simple like maybe the expression y equals x squared, and I just happen to think about that off the top of my head, but we could think about that in an algebraic format, like I just stated, y equals x squared, or we could think about a square with length of size x, and then y represents the total area of that square. And we have the freedom to look at that function in both of those ways. And the beautiful thing about math is we're going to get to the same conclusions, but sometimes we need more imagination to think about problems than what we would, start assuming, because you may start thinking about that as simply an algebra problem. But if you don't ever use your imagination and go to the geometry side of it all, you may miss out on a lot of different perspectives of what that expression represents.
Well, and as you were talking about that, my mind was thinking about the square and the formula. I mean, I didn't have it in front of me, but, and everybody can conceive of it differently, I guess, but that's it. Your mind starts going and and it allows you to imagine things at different levels. But like you said, you had some of that in prior podcasts, and some of the Lazarus math stories on our website have people in history doing this, where they just start imagining things, and they might not even be putting pen to paper yet. They may, but even that, they're imagining, well, how does this work? And crumple, the old crumple up the paper. That didn't make any sense. Let's imagine something different, and I think that's where, well, certainly you find and you innovate, but then you get into back to those words we've been using, you're trying to find the truth of something. You're having some joy doing it, hopefully, and then you're getting into maybe some of the beauty of it too, and that you can't really have that without that imagination being a part of that.
Mm-hmm. And there are different ways that we often describe what math is like, and one way we could describe it is like a tree, and I kind of like that because a tree continues to grow and has branches, and there's different branches of mathematics, and it's always expanding. And also the thing that gives the tree nourishment are the roots. And like in mathematics is the same way, as there's roots to how we got to where we are at. But the key to that analogy to me is that the tree is always growing, and math is a growing subject. We don't often think of it that way because it's often presented to us in a textbook, and our goal is to find the right answer. And that hides the idea that math is very much growing, and we're learning about new things in math all the time. And I feel like there's so much that we can learn from math. It's very unlimited as to where math can go. If you talk to any mathematician, they will tell you they probably got a huge laundry list of things that they're trying to work on, to ponder, to think about, because a good mathematician has a very imaginative mind, and they're always wondering, what happens if I try this? What happens if I try that?
Yeah, that's kind of implicit in being in math, and unless you just, like you said, you stay with just the very concrete, find the answer, which, that has its meaning. I mean, it's good that people do that when we're making bridges, that they know how to do calculus. I think that's great. But math in its pure form, that without that, it just doesn't move forward. It's just because you just continue to regurgitate the same formulas. You just learn what everybody else has done, and you don't even get probably on. You don't even go down the path.
Mm-hmm.
I always thought geometry was fun because there are different ways to getting there. You'd start with given, and then you'd say, you'd go down these and you'd go, oh, wait a minute. Erase 3, but that was what we were doing. You're imagining, and there might be 2 different ways or 3 different ways or however many different ways to come to the same conclusion and prove the hypothesis. So I think you're right. I do think, as we've been talking about this, and I kind of knew it already, and maybe people that have come alongside us in podcasts and videos are starting to see there's something here about just, I guess I'll just call it the term pure math. There's something here deeper than I really probably thought of before we started this process. That you get, I guess joy is the word we're using, but there's just almost a little bit of excitement there, because there isn't, philosophically, there really isn't an actual infinite, if you know what I mean, because when you get there, there's always more. But yet, in our imagination, there actually is.
Mm-hmm.
I think that one there just always kind of like, well, that's really cool. And it does have there's a little bit of beauty in that too, I think. It's just kind of cool. Yeah. Yeah. So I agree. You're getting your imagination to wander a little bit with some parameters can really get us in some pretty cool places with math.
Mm-hmm. And even in the world that you brought up regarding like engineering or finance, where it looks like that there's going to be one right answer. As you know, we've spent quite a bit of our time in the actuarial world, and I've spent a lot of my time in actuarial education. One of the things that I've really enjoyed is to take some sort of concept and play with it, and to be able to look at it from different perspectives. And in doing so, often you can bring different concepts together. And so there might be like 4 or 5 different concepts that are taught that appear to be separate topics. But if you look at them just right, you can see the connection between those. And then you can bring all those together, kind of like connecting dots. And, those types of things require imagination. There's not like anything I read that told me that, okay, here, go connect these dots. That's just something that I had the privilege of working on, because I could invest time in, looking and relooking at these problems. And I was able to look deeper. And in that deeper probe, I found a lot of surprises and ways to look at things in a way that will make it easier for other people to understand it. And I think one of the challenges that we have in current education is that we have to go so fast that we don't have an opportunity to sit and go deep and to see some of those connections. And I don't necessarily have a solution for that. I'm just saying that that's just too bad, because anytime you start looking at math deeper, you're going to find very interesting things, but we often don't take the time to go deep into something.
Well, and I do think, whether we look at the pedagogical, the educational side of things, that I think most of us know when we were going through even, junior high school times, the times we enjoyed were more we got to experience it a little bit, to see. I remember once we did it wasn't dominoes, but they were similar to dominoes. We had to calculate the distance between the dominoes to make the most force so it could get all the dominoes over. And you knew people have seen that. But that was just kind of fun. We were using math. I think I was like a sophomore in high school. But that was the experience, was cool. And when you saw all those dominoes fly and it worked, you're like, oh, wow. There was an experience. There was a little bit of joy there. And I think that's it. I think you see that I'll have to admit, I think it took us like 6 times to get that right. And it's like, okay, that didn't work. Why not? And really it was because, we were being a little bit unimaginative on the math, I think a little bit. I remember we just had the mass wrong on how much each of those little pieces of metal weighed. Once we got that, then we were able to move things and it worked. But again, back to your original point, that it allows, you're allowing people to learn, but we're not, like you said, with education, we tend to think of education with a goal of being a very utilitarian goal of understanding things and getting a job, which is not bad. but wouldn't it be fun to have a job that you enjoyed?
Mm-hmm.
People listen to that right now. Yes, I would like that. Yeah. And not that everything's going to be perfect, but again, back to your stories. I thought that was so cool. It's not like, that Euler was just like, well, this is boring, but I'm going to try to figure this out. No, he really enjoyed it, and I think that's what we're trying to get people to realize, that whether it's math or something else, if you can find something that you kind of got some gifts to enjoy, that makes it all the more fun, and it can be useful, which is a kind of a neat combination.
Well, one of the things I think that is one of the coolest stories about imagination and math returns to, of course, the imaginary number I that we've talked about before. And for those of you who don't recall, the definition for I, the imaginary number, is I squared equals -1. And so that's not a number that's on a real number line. It's called an imaginary number. And it was something that came about the last several hundred years in math, where we just basically defined that number, used our imagination, and called it the imaginary number. And that number has turned into something that's been incredibly helpful, useful, informative, you name it. It has been a darling of math for the last couple hundred years as to how useful that imaginary number has become.
Yeah. And again, it's interesting because the word imaginary has a little bit different, but they cross over. They're not mutually exclusive. I mean, it's not like you were sitting there and the apple hit you in the head and you thought, it's not that type of imaginary. It's a concept that there was a barrier to calculation. And so somebody imagined, and I think that's a good way to put it, this particular thing that allows you to make calculations that you can otherwise make. Mm-hmm. But you can't necessarily draw a straight line to reality, or like you say, a real number line, but certainly useful and have shown itself to be useful, which is quite interesting, I think.
Right. And then in math, we do kind of some fun things. So let's just take a simple function that maybe we can imagine. Let's take y equals 2 to the x. And so if we think of x, let's say, as an integer, then x could equal 1. So that produces 2 times 1. Or x equals 2, then that's 2 times 2, or 4. Or x equals 3, then that's 2 times 2 times 2. That's 8. And when x is an integer, we think of the expression 2 to the x basically as repeated multiplication. And so that makes sense. You probably remember that from high school math, right?
Yep. That was
yeah. So then that's what we started thinking about when we talked about exponents. But then we had this wonderful idea of like, why are we limiting x to be an integer? What happens if we make x a real number? And so that was just like an imaginative idea that someone came up with that had not ever been done before. And so they had to rethink what it meant to have an exponent, because if you have y equals 2 to the x and x equals 3.2148, well, how do you even interpret that? And so you have to kind of now rethink of what that exponentiation process is actually doing.
Right. Instead of just going through the formulas. Yeah.
Yeah. And so then it requires some logic and some thinking as to how you interpret that. Well, then as we expanded our numbers from the real numbers to the imaginary numbers, well, then, of course, people started wondering, well, what happens if we let x equal an imaginary number or a complex number, which is a complex number is just a combination of an imaginary number and a real number. And so if it was hard to try to interpret what does 2 raised to 3.2481 equals, how do you interpret the idea of 2 raised to 3.2i equals? That's hard to interpret, right?
Yeah, definitely. Yeah.
But when math people started playing around with that, they've discovered some really incredible results that, surprised everybody, because it doesn't seem like even, raising something to a power of I even makes sense. So you had to rethink, well, how do we even interpret that? And, so those are things that math people struggled with. But as they worked through the logic of it all, what came out was things that truly were beautiful and opened up whole new worlds to math people.
Yeah. And again, we get back to that term, the beauty, which is obviously somewhat subjective. We realize that. But as you were talking about this, I was thinking in my mind, not my brain. Well, both maybe. The idea of art, where you get an artist and you have to have some talent to do this. I realize that. But, you get a blank canvas. Okay. Paint. Mm-hmm. Well, how am I going to do that? I guess I could just start throwing the brush at, maybe. But again, most people, what do? They start imagining, and I guess now I think of like Euler. Okay. He's not an artist. He's a mathematician, and he's calculate, think, well, he's got his pen in hand or pencil and he's got his paper and he puts a number line and he's, again, it's not exactly the same, but it's similar, isn't it? That you're letting
it is.
The imagination, because I think that's in my opinion, and hopefully it's helpful to people, that's a way of thinking about it, because we kind of get the art idea that's an expression of who we are and what we see and our perspective. Well, that's kind of what you're doing on the math side. The art can be beautiful for other people and have meaning, and so can the math.
Right.
And it doesn't even necessarily have to have a direct meaning to making bridges or anything. It just could be a way to enjoy and just, explore, if not from a better word, I guess.
Mm-hmm. And that brings me to our Eternity series, video series that we did. And the last 4 video series, and specifically the last 2, which would be the 6th and 7th, I explored the expression of y equals e to the x. And we looked at what happens when x was an integer. And then we looked at what happens when x was a real number. And then we took that crazy turn and assumed, well, what happens if x is a complex number? And so in that video series, we worked through an example to see how that plays out. And I used my imagination in the video that I had never seen anyone explain it before. There's a lot of videos on YouTube if you want to see what happens to the equation y equals e to the x when x is an imaginary number. There's a lot of neat videos on that. But the idea that I came up with was to imagine it as a series of dance steps. And perhaps someone else had thought of that before. That certainly could be true, but it was something that I had never seen before. So I was just kind of thinking about how to explain that topic. And I started thinking about it in terms of, okay, there's these numbers that are going on a complex plane. And I started thinking that, this really could be converted to like a dance step. And so that was, me using my imagination in order to explain a concept that is, kind of difficult to grasp and has been explained many different ways. But I just kind of had fun using the idea of thinking about it in terms of dance steps. Now, that doesn't mean that this is like any better of an explanation, but it was a lot of fun for me to think about it and to think that, okay, I have the ability to come up with something on my own that might be different than anyone else has thought of. And it's not like it needs to be rocket science. It just has to be something no one else has really thought about before. And so playing with math in that way truly is an enjoyable experience.
Well, and I think as we kind of wind down here, the idea of it made me think of kind of back to the education idea that perhaps could be helpful to somebody to conceive of it better, than just saying, well, it's a turn every quarter turn or half turn, or which is still what it's doing. But to make it a dance step, it might get in their mind and think, okay, that I understand better because I can conceptualize that much better in my imagination, or you even see it like you did in the video. So I think that shows how you're looking at exploring different ways to see the same thing, but not just that, who knows what might come of that. It's like, oh my golly, Now I look at it this way, and now I see something I didn't see before because of the dance step. I'm just, kind of thinking out loud here. So that idea that the exploration will kind of, cultivate more imagination, and it just keeps going. And I do think the joy is kind of in there too. So as we sum up here, is there anything you want to add in summary as we kind of wrap up our podcast for tonight?
I think it's simply to encourage you to take time to think about math as something that you can use your imagination in doing, and give yourself the freedom to think differently, to think creatively, and don't be afraid of making mistakes, going down the wrong path. Because once you start thinking about, oh no, is this the right way of doing it? That will immediately kill your imagination and your creative spirit. So there will be a time and a place to kind of think about the logistics of it and whether, it's completely accurate. But you need to start out with just trying to think creatively and allow your mind to try something different when you're working on a math problem.
Yeah, so I think that wraps it up well. It's the idea that, that what we started with is, what if you can look at math as a way to awaken your imagination, look at it a little bit different way, to have some joy. And that's kind of what we're trying to do here all the time. So this has been Dave and Brian with Intersecting Us. We hope you enjoyed our podcast this week, and hope to see you, or hope you hear from us soon in our next podcast.
This has been the Intersecting Us podcast. To further engage with Intersecting Us, go to intersectingus.com.